Hello everyone. Today we are seeing the new topic, Banker's algorithm. This is a part of deadlock avoidance technique. So why is Banker's algorithm necessary? In resource allocation graph, multiple instances of the resources gets failed. So we are going for Banker's algorithm. So we'll see the algorithm first, then later we are going to see some of the sequence of the steps and the problems. So here, first we'll see that there are work and finish are the two vectors with length m and n. Here we are going to initialize the work is equals to available. Please remember this. Work is equals to available and finish of I is equals to first. If these are the two conditions available, then we are going for the second step. So we have to assign that all of the resources and the processes becomes false initially. Then we have to change that if check that need of I is less than or equals to work. If these are the conditions, then we have to go further with the third step where work is equals to work plus allocation. Previous work is added up with the allocation. Then we have to change the finish which was false to true. After doing this, we have to check all the processes and check that if finish of I are true for all the processes, then we make sure that the Okay, now we have seen the algorithm. We will see how to solve this problem using Banker's algorithm. So here given with the vectors allocation, max, available, need. These are the given vectors. Here A, B, C are the allocation arrays or the vectors. These are individual. These are resources. A, B, C are the resources. A is one resource, B is the other resource, and C is the other resource. How to read this? Suppose I am going to see this resource 200. It is not 200. It is 200. 2 is applicable for A, that means A is having two resources, 0 is B, 0 is C, that means there are no allocation of the resources 0, 0 for B and C. So allocation is an array. Suppose for process P1, these are the processes P0, P1, P2, P3, P4, 5 processes. P1 is having allocation of 200, that means P1 is allocated with A resource 2 times. B 0, C 0. So this is how we are going to read them. So now we see that allocation for P0 is 0, 1, 0. That means 0 is allocated for A, 1 is for B and 0 is for C. Similarly, we have max array. That means 753 are maximum available resources. A is having 7 maximum resources it can be allocated for. Now it has been allocated with 0. Now maximum process 0 can be allocated 7 resources, not more than that. So now we are given with this data. First step what it says, available is equals to work. So whatever we have available, that is equivalent to work. So available is equals to work. So first step is that. So here I am having the available resource or the work as 332. Done. So now we have to calculate the need array. So how to calculate? So we have to calculate the need array. Need is calculated something like this. Need is equals to max minus allocation. So what is max? Max is for the process P0. Max is 753. We have to calculate the need array by having 753 minus 010. So we have to subtract max minus allocation to get the need array. So here 753 is subtracted with 010. So 7 minus 0 becomes 7. 5 minus 1 becomes 4. 3 minus 0 becomes 3. So this is how we are going to calculate the need. Then next, for next array, next process we have to calculate. 200 is allocation. Max is 322 for this. So 3 minus 2 becomes 1. 2 minus 0 becomes 2. 2 minus 0 is 2. So similarly 302. 902 minus 302. This becomes 600. Next is 222 minus 211. So this becomes 011. Next 433 minus 002. This is 4, 3 and 1. So we have calculated the need array. So after calculating the need array, we have to make sure that finish array is to be done. So first initial step is finish array is false for every process. So we have allocated false for every process, right from P0 to P4. All the processes are not finished. This is what this array is going to mention. So we don't have any process finished yet. All processes are waiting to be executed. So after calculating the need array and after finalizing with the Now we have to check work with compared with need. So need should be lesser than the work. So here I need 743 for the process 0. 743 is needed, but available is 332. So to complete the work, I have to subtract. So we have seen that work is available is 332 and need is 743. So always this condition to be satisfied. Need is less than or equals to work. Then only we can allocate the resource. But here need is 743, available is 332. We cannot justify this resource allocation. So hence the process P0 remains false. Next we will go with process P1. P1 need is 122. But available is 332. So I can available resource A is 1 and here available is 3. Need is 1 and available is 3. So obviously I can satisfy the need. And need is 2 and available is 3. So obviously like this we have to map them and check whether we can justify the request or not. So once these request is possible, then what we have to do is we have to change this false to true. That means I can finish the work for process P1 and then we have to use this work is equals to work plus allocation. What is work? Work is 332. What is allocation? Allocation is 200 for process P1. So these two have to be added. 332 have to be added with 200 allocation of process P1. This becomes 532. So now the new work is 532. So we have to use this one for the comparing for the next process. Process P2 will compare process P2. Allocation of process P2 is 302. Maximum is 902 available. Need is 600. So I need 600. Available is 532. So I cannot justify or satisfy 600 need with 532. So again this state remains false. So I have to go for the next process. Process P3. P3 allocated with P3 is 211. Need is 011. Work available is 532. Obviously I can satisfy 011 in 532. So if I can satisfy 011, then this process becomes true. I can complete this process and hand over. So once I complete the process, that means allocation is added with work. So I am going to add this allocation 211 with the work array. So 5 plus 2 becomes 7, 3 plus 1 is 4, 2 plus 1 is 3. So the new work is 743. So this new work is to be compared with the next process P4. P4 is having 002 as the resource allocation. Need is 431. Can I justify 431 with 743? Yes, I can satisfy. So if I can satisfy, false become true. Then allocation is added to the need. Sorry, allocation is added to the work. So if I add this becomes 7, 4, 5. The new work is 745. So how many processes are yet false? We have to check them. So we have process P0 as false, process P1 as true, process P2 as false, process P3 as true, and process P4 as true. So amongst them, which process is false? We have to compute the resource again and proceed with the same steps. So now we see that process P0 is false, new work is 745. We check the need 743 with 745. Obviously I can sanction all of them. So again this becomes true. This becomes true and new resource allocation is 0, 1, 0. So the allocation of this process P0 is 0, 1, 0 is added up with the work. So this becomes 5. This becomes 5 and this is 7. So the new work is 755. I have available or work as 755. This can be used for the next process which is false. So the false process is process P2. P2 process is not true yet. So we have to use this process. Process P2 is having 302 as allocation. Need is 600. Can I justify 600 with 755? Obviously yes. So I have to use the allocation of this process P2 302 and add the present work. So if I add this becomes 7, 5 and 10. So this is 10. So 10 resources of process A, resource A, 5 of B and 7 of C. So this is the final work we get after finishing this, and now this process becomes true. Once we see that all the processes are true, we have to compute the safe state. So how to compute the safe state? The process which has completed first is to be the process first. So when we are computing the safe state, we saw that P1 process finishes first. Then after that P3 finished because P2 was requiring more need. So P3 finished. Then after that P4 finished. Then after that we recomputed and saw that P0 is not yet completed. So we finished this at the 4th position, and finally we finished the process P2 last. So this is the safe state which we can execute. If we follow this state, then we make sure that there will not be any deadlocks in the process. So this is how we are going to avoid deadlock using Banker's algorithm. Thank you.